Hello again. In this chapter, we're going to talk about a potential problem in the Java code that we write called escaping references. We'll understand why it's a problem and how to identify them. Then we can talk about the strategies that we can use to avoid escaping references, which will include creating immutable collections. If this is a completely new topic for you, then you'll probably realize as you study this chapter that you will have written lots of code with escaping references already. That's okay. The important thing is being able to identify when they occur and to understand their potential impact. Avoiding escaping references can be a lot of work, and many projects don't go to the extent of avoiding them, which is acceptable as long as you understand the risks. So let's start by understanding what an escaping reference is. One of the key concepts of object-oriented programming is encapsulation, the idea that classes contain both the data and the functionality packaged together, with access to this data within a class being strictly controlled. Let's consider this simple book class, for example. This is, I think, a well-defined class. What I mean by this is that the data in the class, which are the title and the author fields, cannot be accidentally changed from outside the class. These are private fields, so they're not visible directly, and we can only set the value of these fields by either calling the constructor or one of the set methods. In other words, it will be difficult for someone to accidentally change the value of one of these data items. We have tightly controlled the access to them. Let's have a look now at another example. Now here, the private field of our customer records class is a map of customer records. We instantiate the map in the constructor of the class, and we have a method to add customers to the map. And that's all fine. But look at the final method here, the getCustomers method. The idea is we want to be able to access the records in the map for iterating, so we can write some client code that looks something like this. So in the client code, I'm calling the getCustomers method so that I can iterate through all customers and print them out to the console. Now, I hope you're comfortable with this. It's very standard Java code, and we even write code like this on many of Virtual Pair Programmers courses. But this is actually not good code. There is a problem here. The problem is the getCustomers method. We now know that this returns a reference to the records collection. It means that the calling code now obtains a reference to the collection, and it can do anything it likes with that collection. For example, I could write code that looks like this. Here I've used the getCustomers method to get a reference to the map, and then I've called .clear on that collection. This has enabled me to remove all the records from the customer's collection, which is not something the original developer of our customer records class wanted me to be able to do. It only wrote getCustomers because it wanted me to be able to iterate them. The author of customer records certainly didn't want me to be able to change the records by calling getCustomers. The reference to the map has escaped from the class in which it should have been encapsulated. It's almost as though we had declared this map as a public variable. So we have violated the encapsulation rules, and the real pain of this kind of circumstance is that we now have a very difficult job in debugging if you find invalid values in the records collection, or for example, if that collection corrupts somehow, because any code anywhere in our system can now both access and mutate this collection. So how do we get around escaping references? Well, the first point to note is that references can only escape if we have methods that are returning a pointer to the object. In this instance, the getCustomers method is returning a pointer to the map. So we're looking for ways to avoid returning pointers to existing objects. Let's view this class in Eclipse so that we can try out different techniques for avoiding the escaping reference. There's a project in the starting workspace for this chapter called Escaping References, so load this project up in Eclipse. So here's my copy of Eclipse, and there are 3 classes in this project. We have a customer class, and this is really simple. We have a constructor that sets the name, a getName method, and I've also defined a toString that also prints out the name. As you can see, there's only one field in this class, which is the name. The customer records class is the one we've just seen on screen. And right now it has this getCustomers method, which is providing an escaping reference to the records map. That's something we're going to try and fix. And there's a main class, which simply instantiates the customer records, adds 2 customers, and then loops through printing out those customers to the console. Well, the first approach, although you don't see this too often in Java, is that we could make customer records an iterable class and provide an iterator to the objects that we want to be able to iterate through. Let's have a go at doing that. So we're going to say that customer records is going to implement the iterable interface, and it will be iterating customers. Now, the squiggly line under customer records will tell us that we need to implement the iterator method. If I just hover over this and add the unimplemented methods, we'll get the method stub for us here. And so all I need to do in here is to return, well, it's going to be the records, the map that's in our class as a private field. I want to get the customers, which are the values. So we'll call .values. And then I simply need to call the .iterator method on that to return an iteration of the customers. Having done this, having made customer records an iterable class, it means in the main method, rather than calling records.getCustomers.values, I can just say for each customer in records. These should now be iterable, and if I run this, I should get both of the customers printed out to the console. Now that looks like a reasonable solution, but it isn't perfect. There's one issue with this, and that is that the iterator has a remove method. I could do here records.iterator.remove, and so this method would allow me still to mutate the underlying collection. So this isn't a foolproof way of ensuring that our reference has not escaped from the encapsulated class. A better solution might be to return a new instance of the collection. So let's go back to customer records. I'm going to leave in this iterable option, although we won't use it anymore. And instead, going back to get customers, rather than returning this .records, let's return a new hash map. And it's a hash map of strings with the key and customer values, and we'll pass the existing hash map into the constructor of the new hash map. All collections in Java have a constructor which accepts an existing collection, and this will create a brand new collection seeded with the data that we've passed in. So by doing this, we're returning a copy of the hash map. This is an important point, so let's just review that. If we have a collection, I've got a list on screen here, which is referenced by a variable, and we set another variable equal to the collection variable, then all that happens, as we know, is that the second variable points to the same object on the heap as the first collection. However, if we create a new collection and we pass an existing collection into the constructor of that new collection, then a new object is created on the heap containing the same data as the original collection. The possible downside of this is that the client is still free to mutate the collection that they have been passed, but it's their own personal copy of their collection. So if they do make a change, well, they're not corrupting the original source data. But this is not a perfect solution, as we can change the underlying objects in the collection. Note that both of these collections have a reference to customer B. If there are fields that can be changed in customer B, then this will impact the original collection. And the other issue is that if the client changes their own copy of the collection, they might think that they're changing the original master copy, which could cause confusion. If we go back to Eclipse, and we've just made now the getCustomers method return a new instance of our customers, if in the main class we call records.getCustomers.clear, can we predict what will happen after that? I've got some code here which is going to loop through the customers. Let's put that back to also using the .getCustomers method. So the question is, does getCustomers.clear clear out the data in our underlying records? Well, I think we can predict that it won't do, because calling getCustomers is going to return a copy of the hash map, and we're calling .clear on the copy. And because it's on the copy, the underlying hash map won't have been cleared. When we call .getCustomers again here, we're getting another copy of that original hash map, and that copy should still contain the values. So if we run this now, I expect we'll still get our two customers printed out to the console. Well, we do. I was right with my prediction. But just looking at this code in isolation, this really looks counterintuitive. We're calling .clear, and then we find there's still values there. So this is not a particularly elegant solution, and in fact the elegant solution to this problem is to return an immutable collection, a collection which cannot be edited. This then makes it very clear where you stand. The collections class contains methods called Unmodifiable Map and Unmodifiable List. Actually, there are other unmodifiable methods, which we'll see in just a moment, but if we pass an existing collection into one of these, we'll get a version that then can't be edited. So let's do that. In our customer records class, let's change getCustomers, and rather than returning a new hash map, what we'll do is return collections.unmodifiable, and in this instance we've got a map, so we'll choose unmodifiable map, but you can see there are other options here for other collection types, and we need to pass the existing map into the method call. So this is going to create for us a new map. It's a copy of the original map, and this copy cannot be edited. Let's see what happens now if we try and edit that map. So I'm going to just rerun the code we've got here. I'm calling getCustomers.clear. Well, we can see we've got an unsupported operation exception. So at runtime, we've immediately been stopped from trying to do anything that modifies the map. So the general advice when it comes to collections is that if you have to return a pointer to a collection, then you should return an unmodifiable collection. When we do that, we avoid the reference escaping from the class. What we actually do instead of providing a reference to the map is we provide a copy of the collection which is completely not editable. So that's okay for collections, but what should we do about other types of object? Let's suppose that we want to add a method into our customer records that allows us to retrieve a single object from the collection. So we'll do that down here. We'll call it getCustomer by name, and it'll return a customer object. And so we'll pass in a string, which is the customer's name that we're looking for. Now, when we created the map, the keys are actually set to be the customer's names. So all I need to do to implement this method is to return this.records.get and the value that is associated with the key of the customer's name. So once again, what we've created here is some risky code. We've provided an escaping reference to the customer object. A client that calls getCustomer by name is going to get a reference to the customer and can now call any of the methods on this customer object that change its values. For example, in customer, there's a setName method, and it could call that and change the customer's name. If we want the customer records class to be well designed, we probably want to retain complete control over access to the underlying customers, and we don't want to allow this kind of escaping reference. So what we want to do is really provide in this method a copy of the customer object, and preferably a read-only copy. Well, this is possible, but it needs some work. The first option is to create a copy constructor for the class. We want a constructor which lets us pass an existing object into it, a bit like we've seen with the collections constructors. This is quite easy to do. We'll go to the customer class. Here's our existing constructor where we can pass in a string value for the name. Let's create a second constructor. And this time, we're going to take an existing customer object as being the parameter for the class. Let's call it oldCustomer. And in the body of this constructor, we're going to go through all of the fields in the customer class and assign the copy that we're creating from the existing version. Well, there's only one field this time, so that's going to be this.name equals oldCustomer.name. But we would repeat that for any other fields if this was a larger style class. Now, if we call this customer constructor, this second version, we're going to get a new customer object. It's not going to be a reference to the existing customer object, but it will contain the same data as the existing customer object. So now in the customer records class, rather than returning the existing customer object, we can create a new customer and return that. So we're going to return a new customer, but we're going to pass into the constructor of that customer the existing customer from our collection. So doing that means that in our main class now, and I'm just going to comment out the line that I know gives us an error, and I'll put this new code in after the loop. So we could now retrieve one of those customers. Let's retrieve it and store it as a customer called John. And we'll set that equal to, then it's going to be records. And the method we created was called getCustomer by name. And we're looking for the customer called John. So that's going to give me a reference to the customer called John. And I could print out that customer's name to the console. And let's just save it and run it and check that worked. Great, so there's our new customer John, and this John should be a copy of the existing customer. So if we're able to change any of the values of the John object, it shouldn't affect the original John within our list. Now, I don't think our customer class has any methods that allow us to change its values just yet. So let's add in a set method to the name field. We'll do that down here. So there's a set method, and if we call that from the main class on our John object, let's change John's name to Derek. Well, if I print out John's name again, just to check it's been changed to Derek, and then let's also print out the list to check that the original John has stayed being called John. So we'll print this one more time. So our original list was Simon and John. We retrieved John, we changed his name to Derek, but in our original list, we've still got Simon and John. So at this point, we've managed to avoid the escaping reference by creating a copy of the original object. We did that by using this special constructor that we created that allows us to pass in an existing instance of the object that we're trying to copy, but we can still in our client mutate that copy. And this could be confusing because the client might think it's changing the original copy. Of course, if the customer object had a private field that was a pointer to another object, then once again, changing the object that we're pointing to could cause us some damage in our original class. So although this is a partial fix, it's probably not a complete fix. We'd only achieve a complete fix if we could provide a read-only version of the customer. Well, we can do that with a little trick, and that is using interfaces. If we create an interface for this customer object, which only has the read-only methods in it, and we return an instance of this interface rather than an instance of this class, then the client that's calling this will not see the methods that can change the customer's state. It might be clearer when you see the code that does this, so let's have a go at it now. In the customer class, I'm going to do a refactor. I'll right-click on customer here and click on refactor, and I'm going to choose extract interface. Now, in the interface, we only want the getName method and the toString. I don't want to include setName in the interface. I think we'll call this customer read only. And we'll click on OK. So let's look at the interface first of all. The interface has just two read-only methods. And when we look at the customer object, if I go up to the top, we'll see it implements customer read-only. It overrides the getName and the toString methods, but it has other methods here like setName and, of course, the constructors. Now, in the customer records class, rather than returning an instance of the customer, if we say that we're going to return a customer read-only, and I don't think we need this to return a copy of the customer now, it'll be enough just to return the current object from the collection. Well, what we've now got is a method that's going to return an instance of the customer read-only interface. The client that calls this method is only going to see the read-only methods, the getName and the toString method, so it won't see the setName method. Let's just prove that in the main class here, rather than our result of John being a customer, it's now a customer read-only. And if I just save this, well, we'll see we can call getName, but setName, it's not happy about it. There's no setName method in the customer read-only interface. So we can't call now setName on this new object. Now, this isn't completely foolproof because a nasty client could guess what's going on here and say, well, if I change my object John into a customer, then I'd be able to call setName on it. I could cast it into the mutatable type, but I think that this at least gives us some level of control, and it certainly would avoid somebody accidentally changing a value, which is really what the point of this lesson is all about. By avoiding escaping references, we stop people accidentally having access to variables that they shouldn't be able to change. One final point on detecting escaping references is that we don't need to worry about references to immutable objects. Let's go back to the customer class for a moment, and we have here a getName method. Now this is returning a reference to the string containing the name of the customer, but this is not a problem, and here's why. Strings are immutable in Java. That is, their value can't be changed. If we have a string, there'll be an object on the heap containing its value that's referenced by a variable on the stack. When we change the string to something else, what happens is that a new object is created on the heap and the reference is changed to the new object. The original object retains its value, in this instance the word John, but it will be garbage collected, of course, if there are no variables referencing that object. So in our customer example, well, suppose we have a customer with a name of John. So there'll be a variable on the stack called cust, which references an object on the heap of type customer, which has a name field, and the name field references another object on the heap, which is the string storing the name John. If we retrieve a reference to the name of the customer, then we'll get our new variable called name, which is a reference to our string with the value of John. But if we try and change the name, well, as we know, a new object is created on the heap to store the string Simon, and the reference for our name has been changed. But note that our customer object is still referencing the original string. So running this line of code to change the name has not changed this reference. It's not changed this value. We haven't, therefore, in this instance, had an escaping reference. And this will happen with any type of object which is being referenced, which is immutable. All the classes in Java that are wrappers for primitive data types, like integer, double, and boolean, for example, are all immutable. And we know strings are immutable, and big decimals are immutable also. If you're not sure if a built-in Java class is immutable, then you can just check the Java docs. So when we are looking for escaping references, what we're looking for is any method that returns an object where the object that's being returned is not immutable. So I'd like to finish this chapter by giving you a little exercise to work through. In the starting workspace for this chapter, you'll find a project called Book Catalog, and I'd like you to open up that project in Eclipse, look through the code and work out what's wrong, identify any potential escaping references and find a way to remove the escaping reference. Once again, pause the video now and have a go at that exercise. If you're happy that you understand that, you don't need to watch the remainder of this video. You can go straight on to the next chapter, but I will talk through what's wrong with this project in the last part of this video. So I hope you've had a go at this project. I'll now talk through what you should have found. We'll start with the book class. So this class has got some internal variables, and there's some get methods. So let's look at what's being returned in these methods. ID is an integer. That's fine because integers are immutable. And in fact, we're returning this as the primitive type. So that's definitely not an issue. We've got some strings being returned. Well, again, strings are immutable, so there's no issue there. A constructor, that doesn't return a value. We've got another string being returned, so another one that's not a problem. And then we've got a getPrice method and a setPrice method. Let's look at each of these. The getPrice method is returning an object of type price. We don't yet know anything about that object, so we don't know if it's immutable. So there's a potential problem here. I'm just going to put a little marker above this method for the moment that says to do. And I think what we need to do is check if price is immutable. If it is immutable, then this is fine. If it's not immutable, then we've got an escaping reference, so we might want to do something about it. And now we've got a setPrice method. Now that's fine, that's not returning anything, but the fact that we've got a set method means that this class, book, is not an immutable class. If we have a reference to book, we can change its price value by calling setPrice. So we know that this class is not immutable. Well, let's look at price next, and so we'll go to that class. Okay, well, we've got a private map and a private double value, and we've got a constructor. That's fine. So we have a method here now called convert, which returns a double. So the double that it returns is immutable, so there's no issue there. But I look down here and see we've got something that doesn't quite look right. It looks like we're mutating a value within our method, and that shouldn't happen. So I think there's a problem here. I'm going to put a little note on here that we might need to do something. We appear to be mutating a value in a get method. I'm saying in a place where we don't expect necessarily to mutate a value. I haven't called this a get method, but it is a method which is retrieving something. So I refer to this in my head at least as being a get method. Okay, well, we've got something that returns a string. That's fine. And down here, we've got something that is returning rates. And what's rates? It's a map. So this is definitely a problem. That's definitely an escaping reference. So let's make a little note on this one. This is definitely an escaping reference. I think we'll carry on going through the code before we change anything. Next, there's a book collection class. Let's have a look at this one. So we've got a private variable that's a list of books. There's a constructor. And here we are returning an instance of a book. Well, that's definitely a problem because we know that our book is not immutable. We've got a set method in book, so that's definitely a problem. Let's put a marker above that one. So fix escaping reference, I think this time. And then we've got a method that prints out some books. Well, that's fine. That's a void method. And we're not changing anything here. We're just printing stuff out. And finally, let's look at the main class. And here we just instantiate the book collection. And we are calling find book by name and printing out the value when it's converted into a different currency. Now, the first problem I think I'd like to fix is going to be this one in the price class, where we appear to be changing a value in a get method. And I'd like to show that that definitely is a problem first. In book collection, there is this method print all books, which prints out the book and its price. So let's run that method before we call the convert. So before we call this line, we're going to do bc.printAllBooks, and then we'll run that afterwards as well. Let's save and run this now. So in our console, we've got all the books printed out, and in the first list, Tom Jones has a price of $9.99. We then call that convert method and we get this value out, and now when we print the books the second time, Tom Jones's price has been changed from $9.99 to $12.48. So we've definitely managed to mutate a value, which shouldn't happen. It wasn't expected. So let's go and fix that first of all. So in the price class, in the convert method, what we want to do is do this calculation and return the result of that calculation, but we don't want to change the value. Well, that's a very easy fix. All we need to do is return conversion times value. What we're returning here is a double. Doubles are immutable, so we're returning a brand new object. That should fix that problem. Let's check it does. I'll just remove the little note up here that we've got a problem to fix before we do it. So let's now save this and run it again. So now Tom Jones starts at $9.99. We get the same figure out when it's converted, but in our second list, it's still at $9.99. We haven't now accidentally changed a value. So that's fixed that problem. Let's now go back through and find the other issues. So in book collection, we've got an escaping reference when we return an instance of the book. And that's a problem because book is not an immutable class, and it's not immutable because of this set price method. So I think what we'll need to do is to create a read-only version of the book. Let's do that. We'll start by extracting the interface. So we'll click on Refactor and Extract Interface. And we'll call the interface book read only, and we want all of the methods except for the one that lets us set a value. So all the get methods are fine, and of course the toString is okay as well. So we'll click on OK here. So we've now got in our project a book read only class, and book implements book read only. So what we'll do when we return the instance from the book collection is we'll now be returning a book read only. And in fact, we can see that that's been updated for us here automatically. So we'll remove that and just check that our code still works. So yes, we've got the list of books here. We've got our figure printed out in the middle, and in the second list, we've still got the correct figures. So is there anything else still to fix? In the price class, we've got an escaping reference to the rates map. Now, there are a couple of different things we could do here. We could create a copy of the map called an unmodifiable map and return that. Actually, I think in this instance that it doesn't make sense to have a reference to return the whole of that map. What would be more sensible is if you can supply the key and retrieve the value. So I think we'll change this method and say rather than returning the map, let's just return the rate that we get from the map, which is a double. So let's change this to a public double called getRate, and it'll take a parameter now which will be a string, which is the currency. Then what we'll return is not rate, but rates.get and the currency. So now we've removed the escaping reference. What we're doing is we're returning a double. Yes, it's a reference to the double from the map, but of course if we try and change that double, that's fine because doubles are immutable. Now that we've done that, I think we can see that price is an immutable class. Once we've created it, there are no methods here which allow us to change any of its values. There are no escaping references, so price is immutable. If we go back to book, we had a question, I think, in here. Let's find it. Yes, check if price is immutable. Well, it is. So returning the instance of price is no longer an issue. So I can take that little marker off. So I think that's done the job. I now think we've got a safe project. There are no escaping references, so this is now working just as it should. I hope you found all of those, and if you did, well done.